next speaker, I believe, is Munish. He is going to be speaking to us today about the technical aspects of processing and presenting raw IoT sensor data using the CCADI framework. So just give me one moment and I'll bring up the presentation.
My name is Munish, and I work as a software engineer for CCADI. And I'm going to be talking today about how we're taking sensor data from our Kluane weather station and transmitting it through the CCADI framework. So I'm going to discuss what our goals are of this whole project, the way we have our data pipeline set up, the challenges we've got, and how we gather and store data, how we attach metadata, and how we're using the process data for visualization and research. So what we set out to do is take raw data from a Campbell scientific weather sensor that's installed at our Kluane Lake station. And then we wanted to use our semantic mediator to describe and understand the data. We also wanted to publish the data in a RESTful API and the Amazon Web Services S3 bucket. And then we're using the process data in different visualizations, like WebMap, Geoserver, things like that. And we're also making the process data available for download in Excel and other software for researchers. So for our data pipeline, we start with the weather sensor, and then we've got a desktop Windows PC set up at the weather station that gets the data from the data logger. The semantic mediator just kind of fits in the middle. It's really only used once to define the fields in our database and our RESTful API. So once that's done, the data can flow from the desktop PC to the Spring RESTful API. And from there, it's stored in the Postgres database and also in S3 buckets. So some of the challenges that we have is the station is closed in the winter, so this has to be set up to run unattended. And the data is also not directly available to researchers when it's just in the sensor memory, so we need to get it out of there. We also have unreliable station power. It's solar power up in the station, so especially in the winter months, the power can go in and out. Same with the internet, it's unreliable, so it can drop in and out as well. It's also a slow connection, so we can't be posting large amounts of data each time via updates. And the data logger only provides like raw text data, so there's no like metadata attached. There's no way to really understand what it is. So this is an example of the sensor that we're using. It's designed for remote environmental applications. It can be programmed with Campbell Scientific LoggerNet software to automate some of the functionality. But it can also set up to get data from a integrated web server, which is what we're using. So it internally logs data every 30 minutes. So we get 48 readings a day. There's an option on it to connect to our Wi-Fi network at the stations. And it also has to be properly positioned and calibrated. So actually, we initially had a problem where the sensor wasn't positioned correctly, so we had to go through and correct the data to get the correct wind directions. So we used a Windows PC at the station to kind of process the data from the sensor. The reason for that is the Windows PCs were already available there, so we wanted to make use of that. And it's just a standard Windows computer on a Wi-Fi network. And we wrote a just a simple Windows application, a Forms application in C#. And it incorporates a UI that shows the data that's extracted from the sensor in the table right on the screen. It pulls at regular intervals to get new data from the weather sensor. And it also keeps track of the last successful retrieval of data. Just because the internet can go in and out, we want to make sure that we're not getting duplicate readings in our system. And so when that's done, when the internet's available, it will post data to our Spring Java RESTful API, and it also posts it to an Amazon S3 bucket. So in the middle here, we had a semantic mediator. This actually wasn't completely ready when we were doing this, so we did a lot of the work in the mediator manually. But the purpose here is to get metadata for the fields that can be useful for researchers. And so this was a custom developed Java API, and it's used for more than just this application. It's also used to serve data to our CCADI web application. So we took this and extended it since it was already available. It's installed on AWS Beanstalk, so it's very scalable as our needs change. It stores data in a Postgres database with PostgreSQL extensions. And I'm using a Java persistence layer as well, so it's a lot easier to work with than doing raw SQL queries. It also automatically checks for duplicate data submissions, so it'll retrieve the last timestamp of data in the database, and it'll only store new data into the database. We also want to post the common delimited data to the S3 bucket. So there's a bit of duplication right now. It's happening in the desktop because that was what we initially set up, but it should be migrated here. And then we've also got endpoints available to query data in different ranges, available in JSON and CSV. So right now, this is designed for internal use. To make it really CCADI compliant, we're going to want to extend it with NetCDF and other open data formats. So the Postgres database, it just stores all of the sensor data, including the timestamps, temperatures, wind speed, wind direction, rainfalls, all the stuff that's available from the sensor. Also some other information about the sensor itself, like battery voltage. And the way it's been set up is it'll work with any kind of sensor in the future, so not just CR1000. It's designed so that you can define fields for each of the sensors and then keep track of the data. So once we've got the data, we want to use it for research. So there's several different services, like our metadata API and our MODAT weather stations. We can display it on an Arctic web map, on our CCADI Geoserver instance, and also in the CCADI web app that we created. So the main purpose here is we've got a MODAT site set up. What that is it compiles data for a number of weather stations in the Arctic. So the Kluane station is just one of them. But we're serving data to this service here as well. And the URL for that is available at the bottom. There's just 6 stations that data is available for right now. We're also working on things like Arctic web map and the dashboard. So the purpose here will be that you can click on different stations in a map and see the data for them. And we're still developing that as well. And we've also got a Geoserver instance set up where we're putting the data from the weather station into Geoserver into a layer for downloading and viewing. And this is our overall web app for CCADI. This links to all of the different services, including the weather data. So it's a responsive web app. It was designed custom in Angular JavaScript. And it provides link to all our services like MODAT, ocean acidification, coastal erosion, and our federated metadata catalog. And for demonstration purposes, we also have a light application for ocean acidification. And we added a page here, there's a screenshot. Just to make it easy for students and researchers to get the Kluane data, they can just go to that page and just request the different date ranges for research purposes. So just to summarize, we're taking the raw data from the remote weather sensor and we're publishing it using open source tools and the framework we've set up with CCADI. The metadata for it would be obtained using this semantic mediation. And the process data is used in a variety of applications, charts and data libraries. Any questions?
Julio, you got your hand up.
Yes, can you explain better the semantic mediator? I don't get what it does.
Sure. So when we're getting information from the sensor, we've just got field abbreviations really. So we want to find out more about what they actually mean. So the semantic mediator can be used to feed in like the abbreviation that's coming from the CR1000 station. And then it will convert it and provide more details, just basically a description of what it would be. And then that description can be stored in the database alongside the field information. So when you query it, you'll get more details.
They kind of extract the data from the.
The metadata, it's just like describing what the fields are in the weather sensor.
That's a manual step. A human has decided that this
Right.
column, or this value is.
We can use, to provide more useful data to researchers.
It's not like a language generation where some algorithm has made a guess at it.
I'm not right. That could be in the future.
Yeah, thanks, Munish. It's a great look at your technical stack, which is really similar to ours, except the S3 buckets. So I'm really curious from a policy perspective as being a Canadian institution, if you've got tremendous pushback from, say, the university or the researchers by depositing stuff in, by just using Amazon services at all.
We haven't really had pushback. The one issue we've had is budgetary. So it's getting the money to Amazon services. So far, we've been able to do that. But the data can be stored in Canadian regions, so there's still no security concerns there.
Okay, so you made sure to use one of the Canadian regions for
Yes,
that to
yeah.
get around that? Okay, yeah, thanks.
Other questions? Okay, I think you're off.
Okay.
So thank you very much.